Hello everyone, welcome you all to today's class. Today's lesson is about trigonometric equations. Okay, so the equation, the term is not new to you. You already have studied algebraic equations in which you are familiar with linear equations in one variable, linear equations in two variables, and also quadratic and cubic equations. Right? So it means after studying algebraic equations, you already are familiar with the term equations. So equations is basically, as you have studied, it is an expression in which you have one or more unknown variables. Right? Now let's see what is a trigo equation. So what is a trigo equation and how to solve it? Okay. So now the theme of today's class is trigonometric equations and inequalities. And today we will be focusing on part 1, I mean the beginning portion, in which we will introduce trigonometric equations. Okay, so trigo inequalities are important for competitive exams. So later on I will be teaching you trigo inequalities also. Now in trigonometric equations, we will be focusing on what is a trigo equation and solution of trigo equations, classification of trigo equation, solution of trigo equations and classification of solutions of trigo equations. Okay, and in classification we will be discussing principal solution and general solution, and of course general solutions of some trigo functions. Okay, so let's begin the introduction part. Yeah, so what is a trigonometric equation? So equation involving trigonometric functions. Yeah, just a moment. Yeah. So whenever we talk about algebraic equation, we know, so we have some variable associated with it, right? Whenever you say x square plus 5x, yeah, plus 6 equal to 0, right? Yeah, 3x plus 2 equal to 0. In such cases, so you know, you have to, I mean, solving the equation means you want the value of the variable. So it means equation always, I mean, it involves a variable, right? So in case of trigonometric equation, so we define like this: the equation involving trigonometric function of unknown angles, that is known as trigo equation. So it means trigonometric function of unknown angles, yeah, unknown angle. For example, whenever we say cos theta equal to 0, so we do not know what is theta. It means theta is unknown to us. So cosine of this unknown angle equal to 0, right? Similarly, cos square theta minus 4 cos theta equal to 1. So again, we do not know value of theta. So trigonometric function of unknown angle, yeah, unknown angles. Okay, that is called trigonometric equation. Similarly, sin x plus cos x equal to 1, right? So it means finally it is like this: equation involving trigonometric function of unknown angles, yeah, unknown angle, that is known as a trigonometric equation. And these are some of the examples. Now from these examples, what you can see, so number one, it is involving an unknown angle. Okay, so whenever it involves an unknown angle, so we have to find that unknown angle. So it means finding that unknown angle means we have to solve the equation. Okay, so it means solution of trigonometric equation. Just like any other equation, yeah, so solution of the equation means what? So it means the value or values of the variable that satisfies the equation, right? Similarly, in case of trigo equation, solving the trigo equation, it means solution of trigonometric equation means, so it means finding the value of the unknown angle. Okay, now let's see. Okay, so here you can, yeah. So whenever we say cos theta equal to 0, as you know, if theta equal to 90 degree, cos theta equal to 0. Okay, yes. The solution of trigonometric equation means, yeah, a solution of trigonometric equation, so it means the value of unknown angle that satisfies the equation. Okay, value of the unknown angle that satisfies the equation. For example, sin x equal to 1 by root 2. So whenever we say sin x equal to 1 by root 2, so we have to think for what value of x, sin x equal to 1 by root 2. So as we know, sin 45 degree equal to 1 by root 2. So it means when x equal to pi by 4, sin x equal to 1 by root 2. So x equal to pi by 4 satisfies sin x equal to 1 by root 2. So it means this is called a solution. Yeah, x equal to pi by 4 is a solution of the equation sin x equal to 1 by root 2. Now the question here is whether we have only one solution or more than that. Now for example, whenever we take, okay, so whenever I take, yeah, as you know, suppose for example, sin x equal to, yeah, so let me take this one, 1 by root 2. Okay, now sin pi by 4. Sin pi by 4 equal to 1 by root 2. Okay, if I write here sin pi minus pi by 4, so it means sin 3 pi by 4 equal to 1 by root 2. If I write here sin 2 pi plus pi by 4, sin 2 pi plus theta equal to sin theta. So this is equal to sin pi by 4, that is equal to 1 by root 2. So we can get many more values. So what we can conclude here, I mean, when x equal to pi by 4, the equation is satisfied. When x equal to 3 pi by 4, the equation is satisfied. And when x equal to 9 pi by 4, the equation is satisfied. Similarly, we can go more also, like we can take, more values also, right? Because sin x is periodic function of 2 pi. So after every 2 pi interval, the angle, the value will be repeated. So it means we can have many more values. So some of the values like this, pi by 4, 3 pi by 4, 9 pi by 4, 11 pi by 4 and so on. Right? So depending upon, like as you know, sin 2n pi plus theta equal to sin theta. Okay, so it means we say sin theta is, yes, sin function is periodic function of 2 pi. So we write like this, yeah. So depending upon the value of n, it means how many rotations you are making, how many times you are covering the circle, right? Whenever you are moving on the circle, so one rotation equal to 2 pi radian. So how many times you are, moving on the circle. So depending upon the value of n, so we can get various values, right? So it means what you can conclude here, So whenever you get any trigo function, so you may have more than one solution. So it means, or you can say a trigonometric equation can have infinitely many solutions, right? So when it has infinitely many solutions, so we can classify accordingly. Yeah. So we can classify accordingly, like for example, yeah. So classification of solutions of trigonometric equations. So we can classify trigonometric equations into, yeah, solution into two types. So one type is like principal solution, okay, and the other one is general solution. Now, principal solution and general solution. What is the difference between the two? Okay, so let me just tell you here before we go for more concepts. Yeah, just so whenever you have principal solution, so as I have written here, the solution line between 0 and 2 pi. So if you remember, whenever we take within the triangle, if I write here, suppose this is x-axis and y-axis. So the coordinate axis divide the plane into four quadrants. First quadrant, measurement of the angle is between 0 and pi by 2. Second quadrant, third quadrant, fourth quadrant. So here you start angle 0. Here you arrive at pi by 2, pi, then 3 pi by 2, then you arrive at here 2 pi. It means you are covering one complete rotation. Okay, it means traveling on the circle once. Means you are covering from 0 to 2 pi. So now principal solution means the solution lying between 0 and 2 pi. In fact, what we can say, so yeah, so for if you see, if x is the x equal to something, so x should lie between, it should be 0 less than equal to x less than 2 pi. Okay, so principal solution is from 0 up to 2 pi, right? So solution lying between 0 and 2 pi. Okay, the value of f lying between 0 and 2 pi, or we can say 0 less than equal to f less than 2 pi. That is the principal solution. Now, what is general solution? As we know, trigo functions are periodic functions, right? So like for example, as you know, if I say sin x, sin 2n pi plus theta equal to sin theta, and cos 2n pi plus theta equal to cos theta, and also tan n pi plus theta equal to tan theta. It means sine and cosine functions are periodic functions of 2 pi. Tan theta is periodic function of pi. Okay, so periodic function means the value will be repeated after certain interval of time. It means whenever I say sine, cosine are periodic functions of 2 pi. So after every 2 pi interval, the values will be repeated. Like for example, sin theta equal to sin 2 pi plus theta equal to sin 4 pi plus theta, sin 6 pi plus theta, and so on. Here tan theta equal to tan pi plus theta equal to tan 2 pi plus theta equal to tan 3 pi plus theta, and so on. So it means you are getting various values, right? So since trigo functions are periodic in nature, a solution can be generalized by periodicity of the trigo functions, right? So it means solution consisting of all possible solutions of trigo equation is called its general solution. So simply said, all possible values. Okay, so it means the solution consisting of all possible solutions of trigo equation. So it means it can be between 0 and 2 pi, or it may be beyond that. So solution between 0 and 2 pi and beyond that interval can be taken as general solution. So general solution, I mean, if I say trigo function, suppose for example, yes, I can take, suppose for example, tan x equal to root 3. Okay, now as you know, tan x equal to root 3 means x can be pi by 3. Okay, now you know sin n pi plus theta equal tan n pi plus theta equal to tan theta. So it means if you write pi by 3, so tan pi plus theta equal to tan theta. So it means pi plus pi by 3. So this will be 4 pi by 3. Okay, 2 pi plus pi by 3 means 2 pi plus pi by 3, it will be 7 pi by 3. And so on. So you will be getting infinitely many values. So but instead of writing like this, so we generalize the solution, right? So let's see how to find it. Okay, so just let me go in brief, just a moment. Okay, so whenever you have such cases, for example, sin x equal to 0, cos x equal to 0, like this. Okay, how many possible values are there? So our next concept is general solution of sin x equal to 0, cos x equal to 0, tan x equal to 0, and so on. Okay, so here like I have shown this, just observe the curve here. Okay, now whenever you are having this green one, that is your sine curve, and this orange one is your cosine curve. It means this green one, green colored graph, that represents sin x, and the other one is cos x. So here you can see this is like the curve is non-ending, and you can see there is a definite pattern in this curve. Okay, and here you see sin 0, 0, sin pi is also 0, sin 2 pi is also 0, right? Similarly for cosine also you can see. Okay, now I will show you how come sin x equal to 0 implies x equal to n pi, cos x equal to 0 implies x equal to odd multiple of pi by 2 for n belongs to any integer. Okay, just let me yes, take you to the explanation part. Okay, so whenever you have such cases, as I said, sin x equal to 0. Okay, so in sin x equal to 0, so let me take you to the known values. So like you know, quadrant concept, you know ASTC rule, right? So x-axis, y-axis. Okay, first quadrant, second quadrant, third quadrant, fourth quadrant. Okay, so let's begin from the simple one. So as we know, sin x equal to 0, right? You know sin 0 equal to 0. So let me write like this. Sin x equal to 0 implies x equal to 0, right? So if you are taking only the triangle, okay, the way you have studied in 10th standard, we have taken only angle between 0 and 90 degree. So one solution can be possible. But here we are moving in the circular system, right? We are moving along the circle. So it means there is no end point. So for example, so sin 0 equal to 0, we know it. Now if I write here sin pi, it means sin pi minus 0, sin pi minus theta is sin theta. So you are getting sin 0, 0, Now if I write here sine 2 pi, so this is also sine 2 pi minus 0 or plus 0, whatever you want to write, एक ही बात है. So it is sine 0, so it means you are getting 0. So what I mean to convey you here, you are starting from theta equal to 0 या angle equal to 0. So sine 0 0, sine pi 0. Again, these are the two positions on x-axis where sine function is 0. Now pi, then 3 pi by 2, then you are arriving at this point. Okay, 2 pi. So it means this is the position you are getting 0, and after completing the circle, you are again you are getting 2 pi. Okay, again you move, do not stop here. You are arriving at this point again. Now you are covering 3 pi. Again you come here. You completed 2 rotations, 4 pi. Again you come here, 5 pi. Now you come here. You are completing 3 complete rotations, 6 pi. Okay. You just keep on moving like this. So if you observe the pattern here, so here you see 0 pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, like this. So basically what I mean to convey you, if you have this x-axis, I mean horizontal line, so you have one position, so it means basically either you are in the left side or right side, right? So it means in both the places, in left side you can see pi, 3 pi, 5 pi. Right side you have 0, 2 pi, 4 pi, 6 pi. So this is the position you are getting all even multiples of pi. This is the position you are getting all odd multiples of pi. So combining both the cases, like I said, 0 pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, like this. So you can conclude x equal to n pi. Okay, any multiple of pi. So either you are getting the angle, I mean sin x equal to 0 means angle is either in the, I mean on x-axis, either it is right side of origin or left side of origin, right? So basically it is on x-axis, right? So you are getting n pi. Is it clear? So you can conclude general solution of sin x equal to 0 is x equal to n pi, n belongs to any integer. Okay, so you can take 0 onwards, or if you are moving in the negative direction, I mean clockwise direction, you can get negative also. So you can take any integer. Okay, so yeah, so this is one case. Second case is whenever you are having cos x equal to 0. So like the sin x case, I will be taking you to the known value, the value you are familiar with. So you know cos 90 equal to 0. That you know. Okay. So here it is pi by 2. You are covering, I mean starting with 0, pi by 2, pi, and 3 pi by 2. Again you are here with, completing one rotation. So you know cos pi by 2 equal to 0. So it means cos theta equal to 0 means you are here on y-axis. Now you see 3 pi by 2. Let's try. Cos 3 pi by 2 means it is cos pi plus pi by 2. Okay. Now cos pi plus theta is minus cos theta. So that means minus of cos pi by 2. So cos pi by 2 is 0. So it is minus of 0. It means 0. Right? So it means, so here we are very, very clear. When x equal to pi by 2, cos x 0. When x equal to 3 pi by 2, cos x equal to 0. And because of the periodicity nature of cosine function, so every time you reach pi by 2, you are covering one complete rotation, because to move on the circle you have to complete one, I mean to come to one particular point on the circle you have to complete the rotation, right? So in that way, so these are the two positions where cosine of the angle is 0. So 3 pi by 2, next you are moving here, it will be 5 pi by 2, right? Come here, it will be 7 pi by 2, again you go here, 9 pi by 2, 11 pi by 2, like this. So are you observing any pattern here? So let me tell you, pi by 2, 3 pi by 2, 5 pi by 2, 7 pi by 2, 9 pi by 2, 11 pi by 2, and so on. So let's generalize this as a formula. It means, observing the pattern, what we can conclude, cos x equal to 0 implies x equal to any, I mean odd multiple of pi by 2. Okay, so sin x equal to 0 means angle will be on either side of x-axis. Cos x equal to 0 means the angle will be on either side of y-axis, right? So angle being on y-axis means it is odd multiple of pi by 2. Angle being on x-axis means it is any multiple of pi. Is it clear? So, and of course, n belongs to set of integers, right? Now next, tan x. So, whenever we set tan x equal to 0, not much difficulty here. So, tan x 0 means sin x equal to 0, right? Tan x equal to sin x by cos x. So, sin x equal to 0 means x equal to n pi. Okay? So it means general solution of tan x equal to 0 means x equal to n pi. Okay, now let's move to the next. Okay, now we have studied sin x equal to 0, general solution of sin x equal to 0, x equal to n pi, general solution of cos x equal to 0, x equal to 2n plus 1, any odd number into pi by 2. Now tan x equal to 0. So general solution is x equal to n pi. Right? Now sometimes we may be given like this. Suppose for example sin x equal to sin alpha. So for example it may be like this, sin x equal to 1 by root 2. Right? So as in the beginning we have discussed, when sin x equal to 1 by root 2, we are no longer restricting ourselves to one value, right? Because we are moving on the circle, yeah, we are studying circular system of measuring the angle, so the angle will be repeated. I mean, for same position, you are getting various angles, right? So, because of this periodicity nature of the trigonometric functions, we have multiple, I mean infinitely many solutions, right? So here, whenever we have such cases, sin x equal to sin alpha. So now maybe I can just derive this one, and for other things I will be telling you the trick. And of course I can tell you the trick for this also. So whenever you get such cases, so let me tell you how to solve the question, because art of solving the question should be known to you. So sin x minus, yeah, we can write here sin x minus sin alpha equal to 0. This implies, so sin c minus sin d, 2 cos x plus alpha by 2 into sin x minus alpha by 2 equal to 0. So here, when product of this and this equal to 0, you can say cos x plus alpha by 2 equal to 0, or sin x minus alpha by 2 equal to 0. Okay. Now cos theta equal to 0. It means theta equal to odd multiple of pi by 2. So it means you are getting x plus alpha by 2 equal to n, 2n plus 1. Just a moment. Okay, so whenever you have x plus alpha by 2 equal to 2n plus 1 into pi by 2. Okay, and for this one you can get x minus alpha by 2 equal to n pi. So it means you are getting here, I'm just writing, so you are getting two cases. In one case, x equal to 2n plus 1 into pi minus alpha. The other case, this case, you are getting x equal to 2n pi plus alpha. Okay, but we will not be remembering like this. Formula should be understood in a proper way. So whenever you can observe here, whenever it is odd multiple of pi, we are getting minus alpha. Whenever it is even multiple of pi, we are getting plus alpha. Okay, so from this what can be generalized? Okay, so you are getting two cases. In one case, whenever it is even multiple of pi, we are getting plus alpha, and whenever it is odd multiple of pi, we are getting minus alpha. Okay, so what we can conclude here, x equal to, if I write here n pi plus minus 1 power m into alpha. Okay, so let's verify this. What is m? M is any integer, right? So it means whenever we get m equal to even, अगर m even number होगा, m को हम 2n मान लेते, so in that case 2n pi plus minus 1 power even into alpha means you are getting this case. अगर m odd number है 2n plus 1 मान लेते है ना, so in that case 2n plus 1 into pi minus 1 power odd number into alpha means minus 1 into alpha. So you are getting this case. So it means as a formula, as a concept, if we want to remember it for application purpose, we can have sin f equal to sin alpha implies x equal to n pi plus minus 1. This implies x equal to n pi plus minus 1 power n into alpha. Okay, n belongs to any integer. Okay, so this is the way. And why are we getting like this? So if you want to remember the trick, maybe for objective types of questions, it will help you when you don't have to have the write-off, when you don't have to write so many steps. So here you see, you are getting here like even multiple of pi, right? This is the position of 2n pi. This is the position of pi, 3 pi, 5 pi, like this. Means this is the position of 2n plus 1 into pi, right? So you are getting all even multiples of pi here and all odd multiples of pi here. Now, even multiple of pi plus alpha means you are getting angle in the first quadrant where sin x is positive. Similarly, whenever you are getting 2n plus 1 into pi minus alpha means you are getting angle here in second quadrant, and in second quadrant sin theta is positive. So it means getting such formula has the significance, I mean, it has its own significance. So angle is either in the first quadrant or in the second quadrant. Okay, so angle in the first quadrant is in the form of even multiple of pi plus alpha. Angle in the second quadrant means it is odd multiple of pi minus alpha. Is it clear? So I think if you have understood the concept, you will never ever be able to forget it. Okay, so let me just take you to cosine and I will tell you the trick there. And now you know how to solve it. Okay, so suppose for example, yeah, cos x equal to cos alpha. Angles having same cosine. So to solve it, you can do like this. Cos x minus cos alpha equal to 0. Then you can have, I mean the way we have done the previous case, it is like this, minus 2 sin x plus alpha by 2 into sin x minus alpha by 2 equal to 0. Now the difference of two angles we have expressed is a product of angles. So it means a product of terms. So it means you can have sin x plus alpha by 2 0 or sin x minus alpha by 2 equal to 0. It gives us x plus alpha by 2 equal to n pi. Okay, so here you can get x minus alpha by 2 is also n pi. So from this case you can get x equal to 2n pi minus alpha, or from this case you can get x equal to 2n pi plus alpha. So it means combining the two cases we can get x equal to 2n pi plus minus alpha. Okay, so why we are getting such result? The trick is, as I said, this derivation is for solving the questions in, if the question is like 2 marker, 4 marker type of things, 2 marker or 3 marker, right? Yeah, I mean subjective types of questions. But if you get objective types of questions, you need the trick also. So here you see, now cosine is positive either in first quadrant, I mean cosine is positive in first quadrant as well as fourth quadrant. ASTC rule, right? So whenever it is in first quadrant, you have 2n pi here, right? Even multiple of pi. Now, so whenever you are moving this, you are getting 2n pi plus alpha, plus theta. When you move like this, you are getting 2n pi minus alpha. Okay, so this is the reason also, because this is the way to solve the question. Now, if you want to know the trick is like this, either in first quadrant or in fourth quadrant. When it is in first quadrant, 2n pi plus theta. Whenever it is in fourth quadrant, it is 2n pi minus theta. Is it clear? So it means the general solution of cos x equal to cos alpha implies x equal to 2n pi plus minus alpha. So how to apply this? Suppose for example, I write here cos x equal to 1 by root 2. Okay, find the general solution. So this implies, cos x equal to 1 by root 2 means it is cos pi by 4. So cos x equal to cos pi by 4. Here alpha means this is the constant and x is the unknown. Okay, this is variable, this is unknown, okay, and this one is a known value. Okay, just like pi by 4, pi by 6, like this. Now, whenever we have this thing, so this implies x equal to 2n pi plus minus pi by 4. Okay, do not forget to write down this. N belongs to set of integers, right? So this is the general solution of cos x equal to 1 by root 2. And one last thing I will tell you before we wind up the class. Okay, so whenever you have tan tan x equal to tan alpha. Angles having same tangents. So if I write here sin x by cos x equal to sin alpha by cos alpha, right? Alpha is constant, I mean known value, x is unknown value. So you have sin x into cos alpha minus cos x into sin alpha equal to 0. So which gives you sin x minus alpha equal to 0, right? So it is in the form of sin theta equal to 0. Here sin x equal to 0 means x minus alpha is n pi, and this implies x equal to n pi plus alpha. So it means the general solution of tan x equal to tan alpha is x equal to n pi plus alpha. Okay, and here n belongs to set of integers. Now again, why this? Why are we getting such pattern? So here you see, n pi plus alpha. So n pi means you are getting these two positions. Okay, n is any integer. So here you have like all even values of n. 0, pi, 0, 2 pi, 4 pi like this. Here you have pi, 3 pi, 5 pi like this. So n pi means either the angle is here or here. Now n pi plus alpha means angle will be here or here. Where n is even, you are getting 2n pi plus alpha in first quadrant, and when n is odd, I mean 2n plus 1 pi plus alpha in third quadrant, right? So, and I mean first and third quadrant, in both the quadrants tan theta is positive. Okay, so it means whenever you are getting the angle like this, either it is here or here. So theta, then pi plus theta, 2 pi plus theta, 3 pi plus theta, 4 pi plus theta, 5 pi plus theta, like this. Okay, so is it clear why are you getting the such format? One thing is we are solving it algebraically. The other thing is why, I mean the logic behind this. Okay, trick wise you can remember also, right? So these are the concepts we covered today. So maybe in the next class, next session we can cover some questions, and maybe inequalities we can start. So before winding up the class, suppose for example you have tan x equal to root 3. So as you know, tan x equal to root 3 means the basic value, as you know, it is tan pi by 3. Okay, now you are moving along the circle. So tan x equal to tan alpha, right? As I said, x is unknown, alpha is known. So x unknown, pi by 3 is known. So x equal to n pi plus pi by 3. This is the general solution, and as I said, do not forget to write n belongs to set of integers. Okay, so these are the some of the concepts in store for today, and as I said, next class we will be meeting with what? We will be studying some questions, some basic questions, right? And also inequality we will be covering. Okay, and inequalities will specifically, it will be required for competitive exams. Okay, so thank you so much, and let's hope to see you in the next class. And in case you like the video, if you feel it is useful to you, so please share with your friends and subscribe it if you have not subscribed yet, and do not forget to press the like button. Okay, so thank you so much.